So we are recording right now. Don't worry if you are tuning in, your faces are not being recorded, just the presentation and the voiceover. So if you're concerned about that, no worries. Welcome if you're just joining us. We're happy to have you here for our Planets in Motion Tour of the Night Sky video or Zoom presentation. I see a lot of people are just now signing in, so we're going to give them about 2 more minutes to welcome those last patrons. This is so great. There's so many people here. I'm so excited. So right now everybody is on mute. If you want to turn on your video camera, your camera on your computer, you're welcome to do that. You don't have to. If you just want to watch the presentation and not be viewed, that's okay. Your camera will not be recorded as part of the presentation. It'll just be the presentation and the voiceover recording. But we are recording right now. We'll go ahead and get started here. So the Oakland Astronomy Club has been part of the Rochester community for 35 years. The club is a nonprofit organization of amateur astronomers who promote the enjoyment of astronomy through educational outreach at local community events, nature centers, and through monthly viewings at the Addison Oaks County Park Telescope platform. Typically, educational presentations are followed by the club members sharing their telescopes, providing a magnified view of the night sky. This summer, in lieu of personal telescope sharing, the club is sharing their passion online. We are pleased to have with us tonight John Panuto and Gary Dietz from the Oakland Astronomy Club to share a fun evening about finding our way through tonight's July sky. During the presentation, Gary will be manning the chat window. So if you have any questions as you listen, please chat with Jerry. He will respond to as many questions as he can and may defer some questions or topics to a general interest to the question and answer portion of the program at the end of the presentation. If you would also like to wait until then to ask your question, you're welcome to do that as well. Does anybody have any questions so far, or anything they want to ask, or maybe about how to use the chat on Zoom, or anything we'll be covering, or anything like that? For right now, we are going to ask that everybody keep themselves muted until the question and answer part of the program. Again, you are welcome to chat with Gary, and he will be available for questions during the program. And then at the end, we'll have time for more. So without further ado, I'll turn it over to John.
Thank you very much, Tierney. Hi, my name is John Panuto, and my co-presenter tonight is Gary Dietz. Gary and I are amateur astronomers, members of the Oakland Astronomy Club, located here in Rochester. For us, astronomy is a hobby, but we're all amateur astronomers. Anyone who looks up with curiosity and interest at the night sky is an amateur astronomer. On behalf of Gary and I and our fellow club members, with a special thanks to Tierney and the staff at the library, we'd like to welcome all of you and congratulate you on your curiosity and interest in sharing tonight's sky with us. We'd also like to give a grateful shout out to Dana Towsley, a very talented member of our club. Almost all the photographs of heavenly objects that we'll see in the presentation were captured by Dana, so thanks, Dana. The goals for tonight's presentation are on the screen. Tonight we'll share some fun facts to help you enjoy the night sky. We'll share with you how we find our way around. And to do this, we'll identify the bright stars that are in the sky tonight and the familiar star patterns, both asterisms and constellations. Time permitting, we'll highlight some of the hidden gems in the summer sky, and we'll do our best to answer questions that were sent in by some of our viewers. Before we get started, though, I'd like to ask you a question. I'd like to get your opinion. How many truly bright stars do you think that you can see from where you live? So Tierney, if you could put up our first survey question, number 1, let's see what people think. So from our backyards, how many truly bright stars do you think we can see on a good summer night sky in July? It looks like we're
Yeah,
starting to get some answers there.
we'll give you about 30 more seconds to put in your answer. No pressure. All right, last second to put in your answer, and I will share the results.
I am astounded. 20, 20, 20, 20, 20. Every one of those answers got 20%.
So
Is
you
that
should be
fun?
able to see the poll results now, and
Yeah,
everybody can see everything.
that is so fun. Well, let me ask you, would it surprise you to learn that from where we live, there are only 6 truly bright stars in the summer sky? Would it surprise you to learn that for the rest of the year, there are only 10 additional truly bright stars visible from where we live? So maybe it isn't so hard to find our way in the night sky after all. For a moment, let's clarify what we mean by bright stars. By bright stars, astronomers mean how bright the star looks to us as observers here on Earth. Since the times of the early astronomer Hipparchus in 150 BC, astronomers have attempted, somewhat subjectively, to rank the stars by their apparent brightness in a system called magnitude. The early magnitude ranking scheme worked this way. The brightest stars were ranked as number 1, or first magnitude stars. The next brightest were 2s, then 3s, 4s, 5s, until Hipparchus cited the dimmest stars visible to his naked eye, and these he ranked as 6s. With the invention of telescopes around the 1600s, early 1600s, astronomers could see stars dimmer than 6th magnitude for the first time. Sooner or later, the ranking system would need to be revisited. So in 1856, a more precise measurement of magnitude was introduced by an English astronomer who proposed using the very bright and easily found star Vega, one of the bright stars we'll explore tonight, as a reference star for a new measurement of magnitude. With Vega defined as a magnitude 0 star, every other star would be dimmer than Vega or brighter than Vega, but still keep that ranking idea. So the dimmer stars are 1s and 2s and 3s. The really bright stars go negative all of a sudden. Kind of interesting. So each succeeding star magnitude, no matter which direction in this new ranking scheme, ranks the stars that belong to that level as 2.5 times dimmer or brighter than the stars of the preceding magnitude. So in this example, first magnitude stars are 2.5 times less bright than Vega. Stars with a -1 rating are 2.5 times brighter than Vega. And there aren't a lot of stars like that, to tell you the truth. All the stars we're going to look at tonight are first magnitude stars or brighter. So let's see what those 6 bright summer stars are. I'm going to simulate the view of these stars by using a planetarium program called Stellarium that I'm running on my laptop. And I'll use Stellarium several times throughout the evening to set the scene for what we can see. This program lets me show some stars that are either brighter or fainter. I can show asterisms and constellations and even deep sky objects. Tonight, I'll mostly use it to change the way the sky looks at certain dates and times. So I have set the program so that it shows us stars that are a magnitude 1.9 or better, which means we'll see any first magnitude star and any stars brighter than first magnitude. So let me share the screen now. And there it is. So if you look, we're looking in the southerly direction here, and you'll find there's 6, you have to kind of ignore this, but there's 6 bright stars on the screen. And there they are, 1, 2, 3, 4, 5, 6. These are the 6 bright stars of summer, and we'll learn their names as we go. All 6 of these stars are visible tonight at about 10:30. And tonight looks like it's going to be a nice night to look at the stars. As the evening gets later, the sky gets darker, and these stars will pop out even more. For the moment, I'd like you to look at the stars on the screen and make a mental note about what is similar or different as you look at each star. Certainly altitude or distance above the horizon is one of the differences. It's pretty obvious to see. There is one special thing I'd like you to take note about these pinpoints of light, though, and it takes a bit of a keen eye. It's colors. If you look really hard, you begin to notice that not all of the stars are plain white. For example, Antares here towards the bottom of the screen looks a little reddish, and Spica over here on the right looks a bit bluish. I call this variety of colors to your attention because the color of a star tells the astronomer a lot about the star. How old the star might be, how hot the surface of the star is, and how bright it really is. What naturally occurring elements like hydrogen or helium are present in the star, and more. As you gaze at the stars, try to notice their colors. From our vantage point as observers, not scientists, the colors certainly add to the beauty of the stars. And knowing a little bit about these colors makes it even more special. So let me share just this much. Of these stars, Antares is the cool cucumber of the group. It's just about 5,800 degrees Fahrenheit. And of these stars, Spica is the hottest star in the sky tonight, just under 47,000 degrees Fahrenheit. And the rest of the stars, Arcturus, they all fill in the gaps between those two extremes. So we're kind of interesting. We're very fortunate to have all of those stars that we can see tonight. But before we leave this view of the night sky and go back to our story, I want to take you for a quick spin around the sky. So we're looking in the south, and I'm just going to move the sky all the way around just so you can see that I've set the magnitude limit to be 1.9. And as we look around, are we going to find any other bright stars on the horizon? Now we're looking to the north and the northeast, and we're coming back around against that same set of stars. So it looks to be the case that indeed, odd as it might sound, there are only 6 truly bright stars in the summer sky. So let's go back to our presentation screen and ask ourselves this question. We know that from our backyards even, we can see more than in the night sky than just those 6 bright stars. So where are the rest of the stars? Where's the North Star, Polaris? Isn't it the brightest star in the night sky? Where are those patterns that we usually see in the night sky? Well, our mission tonight is to fill in the blanks. And we're going to try to get a firm grasp on a few ideas, then follow the dots to fill in the blanks as we go. So there are bright stars, not so bright stars, and recognizable star patterns. We need all of these to find our way around the night sky. About those patterns, remember in the beginning we said we want to make this easy. We want to make it easy for you to find your way around the night sky. Well, what if I told you that just like there's only 6 truly bright summer stars, there's also just 8 famous patterns of stars in the summer sky? Not bad, not a lot to learn. And even better, 3 of those patterns are visible all year round. So really there's only 5 distinctive summer patterns to know. So maybe this astronomy stuff isn't that hard. Well, let's start by talking like astronomers. Astronomers have a name for star patterns that form an easily imagined shape in the sky, like the Big Dipper. That name is asterism. We call these easily recognized shapes asterisms. Fittingly, the word asterism comes from the Latin. The word is for stars in Latin is astra. In a minute, we'll see the difference between asterisms and constellations. Before we visit these 8 asterisms, I'd like to find out from you which of these is easiest for you to recognize. So Tierney, if you could put our next survey question on and take it from there, please.
Absolutely. So which pattern of stars in the night sky is easiest for you to recognize? So the first one is the Big Dipper in Ursa Major, the Little Dipper in Ursa Minor, the Big W of Cassiopeia, the Teapot of Sagittarius, the Summer Triangle, the Northern Cross in Cygnus, the Keystone of Hercules, or the Kite of Bootes. So I'll give you about 30 seconds to pick out which one you would like to recognize as the one that's easiest for you to recognize.
I'm watching the survey build up, and it doesn't look like there's a lot of diversity here. I think that we have a clear winner.
Yeah, okay. We'll go ahead and end our poll. We do
So
have
there it
a
is.
clear winner.
Yeah, 75% of us think that the Big Dipper in Ursa Major is indeed the easiest of the night sky star patterns to find. And I couldn't agree more. Let's see here. So we're going to talk a fair amount of time about star patterns, especially asterisms like the Big Dipper, easily recognized patterns in the sky. Later on, we'll talk about bigger star patterns, patterns of stars that from ancient times people have called constellations. And finally, we'll go really big when we talk about galaxies. Our story tonight, however, it all starts with the Big Dipper. You may remember that we looked all around the sky in every direction just a second ago. We didn't see the Big Dipper, did we? And not because it's tiny. It's huge, a huge group of stars. Its stars are just not the brightest stars. It's the pattern that catches our eye, not just the brightness of the stars. This picture of the Big Dipper was taken from NASA's Juno spacecraft. It gives us a very good idea of just how huge this pattern of the Big Dipper is. It pretty much really looks like this in the night sky too. Can you make out the pattern here? Here's the handle stars of the Big Dipper, the three handle stars, and here's the four stars of the pot of the Big Dipper. Everybody got that? So now that we know the shape we're looking for, let's figure out where to look for that star pattern tonight. And because it's such an important star pattern, we'll make sure that we know how to find it every night of the year. Seasonal stars come and go, but where we live, the Big Dipper is with us all year long. So we were looking in the southern sky earlier where we found all six of those seasonal bright stars of summer. But to find the Big Dipper, the first of our three asterisms that can be seen all year long, we need to turn around and face the northern sky. Try doing this with me. As you face the north, put your left arm halfway up the sky. Go ahead and do that. And try to imagine a giant clock face in the sky. Now put your arm all the way up and make a great big clock face with your arm. At 10:30 this evening, the Big Dipper will be positioned on this imaginary clock face right about where the hours 9 and 10 would be. So if this was our clock, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, and 10 o'clock, as you can see, the Big Dipper is going to be right about there. And tonight, the handle of the pot will be pointing pretty much straight up in the sky, as you can see right there. So tonight, the Big Dipper is here on our imaginary clock. But since the Big Dipper is so important, and I want you to be able to find it all year long, because it's visible all year long, the question I'd like to pose is, will it always be found in that same spot at 10:30 every night? So I'm going to go back over to our planetarium software again so you can see this for yourself. Let me switch over to the planetarium software. And there it is. And I'm going to need to set the scene. Remember, we were only looking at stars that were magnitude of 1.9. So I'm going to want to look at stars that are just a little bit brighter than that. Remember, we said the human eye can only see up to a limiting magnitude of 6. So we're going to set that to what we can see. Here we go at 6, and we're going to get rid of some of these confusing labels off the side here. What else we need to do? We're going to change and admit that we do have light pollution where we live. And I think that should be pretty much all of it. And if I turn us to the north now, because we were looking in the south, and I need to look in the north to find the Big Dipper. So we'll turn ourselves to the north. And here it comes. You may recognize it on the screen right about now. I don't know if you can see it, but there she be. There's the Big Dipper. All right, so let's turn on some stick figures so we can see it a little bit easier. And the last thing I'd like to do is highlight a star called Polaris. So just to restate our question, we want to know at 10:30 every night, will the Big Dipper be in the same spot as it is tonight? Well, first let's try a small experiment. Does it move at all during the night? So I've got the clock set right here. It's 10:30 on tonight, July the 13th. And if I roll the clock forward just a little bit, just a few minutes, here it is, just 45, quarter to the hour. It's not even 11 o'clock. You can see that the Big Dipper does indeed move. So we can tell this much for sure, that the Big Dipper will be in a different part of the sky depending on what time tonight we look for it, especially if we stay up late. Just for fun, let me show you that. If we stayed up until past midnight, and now it's 3 o'clock in the morning. Oops, let me make that 3 o'clock in the morning. Look where the Big Dipper would be. It was up here, and now it's way down here, kind of almost scraping the horizon. So we've answered one question that, depending on what time we look for it, we need to know that it moves. But back to our question, will the Big Dipper always start out at the same spot at 10:30 every night like it is tonight? So let's go back to tonight, July the 13th, and we'll say that it is, again, 10:30 at night. Okay, we're going to start out at the same spot. We're going to move forward just one day. Let's see what happens when we move forward one day. So tomorrow night at 10:30, here's where the Big Dipper will be. Not in the same spot. And the next night, and the next night. So it's pretty clear that we have got to be a little bit savvy when we're trying to find the Big Dipper. The answer is that for sure it's going to be in the north sky, all right, and it will be found somewhere on that imaginary clock that we painted with our arms just a moment ago, but it won't be starting out at the same spot tomorrow night as it is tonight. It's always on the move. So to summarize, find the Big Dipper by looking north, halfway up the sky, follow an imaginary clock with your raised arm, and remember to look all around the clock face. Don't get dizzy. Sometimes you have to look straight above your head because it's going to be at the midnight mark. So let's ask ourselves the question, why is it so important to find the Big Dipper? Do you remember as we watched the Big Dipper moving around the night, there was a point that did not seem to move. That point in the sky is where the top of our planet points to. That point in the star is right here by a star whose name is Polaris. And in this way, Polaris provides an anchor point for what we call north. So we can find our way around both on land and sea and sky by being able to find Polaris. So it's really important. I'm just going to just show you one more time as you watch. I'm going to put the lines back on again, but here's our asterism. You'll see that not only the Big Dipper, but all of the other stars are going to move through the night like this. And they all seem to move around that one star right there that doesn't seem to be moving, and that star is Polaris. So one other point, why is the Big Dipper so important? That's where the Big Dipper comes into play, finding north. The Big Dipper is easy to find, and using it, we can find the star Polaris. Take a look at these last two stars of the pot or the bowl of the Big Dipper. They will always point to Polaris. Watch this. Even as I move, doesn't matter what hour of the night, it doesn't matter which day of the year, it's always true. Those two pointer stars are going to point us to Polaris. And it's so important because we need to be able to find north in order to find a starting point where we're at. So we're very fortunate because where we live on planet Earth in Rochester, Michigan, in the northern hemisphere, 42 degrees above the north of the equator, because from here, Polaris and the stars of the Big Dipper are always visible. They never go below the horizon here. See that? It's always above the horizon. But people who live below the 41st degree of latitude cannot see the whole Big Dipper all year long. So most of the stars that we see change from season to season, not the Big Dipper. And there's two important reasons that describe why we see what we see. I had a small little heart murmur there as I watched my lights flicker, and I thought, oh no. But everything is okay. So anyhow, so the first two things, the first of the 2 points is that as the Earth spins on its axis once every day, it gives us day and night. And at night, it shows us Polaris and the Big Dipper at our latitude. The other important motion of the Earth is that it circles around the sun throughout the year. So these two movements of the Earth, its daily turn on its axis and its annual path around the sun, explain why the stars are a slowly changing nightscape, a beautiful nightly light show. Well, we were talking about patterns, and we found our first asterism, the Big Dipper. Remember, we said we'd talk about patterns and bigger patterns. Well, big as it is, the asterism of the Big Dipper represents only some of the stars in an even larger pattern of stars. Our ancestors had less light pollution, so they could see more stars than we do from where they lived. And I think they had more imagination than we do too. They saw some really big patterns in the sky, and they told some great stories about those patterns. That tradition of ancient star patterns and tales has a name too. Those patterns and their stories are commonly known as constellations. The asterism of the Big Dipper is one part of a constellation of stars that our ancestors called the Big Bear. Let's set the scene so we can see this a little bit better. So I'm going to set our time back to tonight, the 13th. Whoops. And I'm going to set it back to the same time, 10:30 at night. Okay, so here we are. Okay, so remember I had turned up the brightness of the stars. So the stars we're looking at are pretty much all you can see with your naked eye. But watch me for just a second here. Here's this Big Dipper that we're accustomed to seeing, and it was part of a much larger constellation of stars, more like this. So what our ancestors saw was a bear, and this was the tail of a bear, and this was a saddle that someone could ride on the back of the bear, and this was the rest of the bear's body, and here was the beginning of its head, that was its eye, and there was its first front paw, or leg, and its paws. There was a back leg and some paws, and another back leg and some paws. And if I turn on a picture of artwork, you'll see that it looked like that in their imagination. There it was, the tail, there was the seat, there was the eye of the bear, there was the front paw, and there was the back paws and legs. So kind of interesting. So in this traditional view, that's what we see. Well, for our eyes, the shape of the Great Bear, like so many of the other constellation patterns that our ancestors saw, honestly, it's hard to imagine. So don't feel bad if you have a hard time seeing the Great Bear. First of all, the stars aren't as bright as they once were, at least on account of the light pollution. And secondly, you got to have a lot of imagination to see that bear. So let me share something fun with you as we go back to our storyline here. So here's that traditional drawing again, where there's the tail and the seat and the eye and the legs and so on. If you're like me, the bear is a bit of a stretch. And now that I think about it, I don't think bears really have tails anyway. So what kind of a pattern is that? Many stargazers have dreamt of star patterns, not just the ancient. It may surprise you to know the name of one famous modern star dreamer is H.A. Rey. You may know H.A. Rey as the author of the Curious George books. In his heart, he was also an avid astronomer. Like many of us, he had a hard time finding the traditional shapes that ancient astronomers saw in the night sky, so he reimagined many of those shapes in his own way. Here's that traditional stick drawing of what the bear might look like, and here's what H.A. Rey did. Instead of a tail, he sees the head of the bear. Again, he sees a saddle for the rider, but now the legs are all going this direction. And I don't know about you, but to me, this one on the left looks a whole lot more like a bear than the one on the right does. I like the stick figures a lot. So H.A. Rey's drawings have been widely adopted by other astronomers, by authors, by teachers, even college teachers, because they help us find familiar patterns in the sky. Two famous books that H.A. Rey wrote were The Stars, A New Way to See Them, and Find the Constellations. Each of these books are available at our Rochester Hills Public Library. And if you're waiting in queue for the H.A. Rey books from the library, you can also go online and find these same stick figures. I found them for you at a place called inthesky.org. It's also available within this software, Stellarium software that I'm using, or at a place called stardate.org. Don't worry about the names. At the end of the presentation, there's a citation page. Everything I've talked about will be on that last slide so you can see the citation page. While we're talking about borrowing things, sign up to borrow the library's binocular kit. You will absolutely be amazed at how many more stars you can see with binoculars. Well, H.A. Rey is not the only storyteller who found a new way to look at the stars. Can you see the pattern of the Big Dipper in this picture? This image shows how the Navajo Indians saw those same stars that we call the Big Dipper in the constellation Ursa Major. Let me trace the pattern of the Big Dipper that we're accustomed to seeing, and you may be surprised that the stars in the Navajo sky are the same stars in our sky. Hopefully it starts to look a little more familiar. So there it is. The Navajo kids were taught to see the revolving mail, and we were taught to see the Big Dipper. Traditions in other cultures have looked at the same stars and seen other shapes as well. Some see a plow for tilling the soil. I can see that. And some have seen a butcher's meat cleaver, and I can see that too. There are almost as many imagined shapes as there are cultures. So not everybody sees the same thing when they look at the sky. What's the takeaway? First, do look up and enjoy the stars. They're yours to imagine. See what you see. The stars are yours to marvel at. Secondly, it is easier to share the night sky with others when we all imagine the same star patterns. Agreed upon patterns, stick figure drawings, the stories about these imaginary figures, they really do help us to find our way in the night sky. Well, we're still on our first asterism, the Big Dipper. The good news is that now that we can find the Big Dipper, we can use it to find a lot of other interesting objects in the night sky. Next up for us is double stars. One of the most famous double stars is found in, guess what? The Big Dipper. The main stars in this double star formation are Mizar and Alcor. And unlike many double stars, people with keen eyes can actually see the second star, Alcor. In fact, in olden times, finding Alcor was considered a test for just how good your eyesight was. Let me show you quickly how one star actually hides another star, and I'm going to switch back to our planetarium software, and we're going to hone in on this guy right here whose name is Mizar. He's the second star in the handle, or the middle star, call it what you like. We're going to hone in on him, and we're going to begin to zoom in, and as we do, you'll notice that that star seems to grow just a little bit. It looks like it's sprouting something else, doesn't it? And there it is. Finally, from behind Mizar, we can now see Alcor. So I'm going to take that back. You can see how deceptive that is and how easy it is for one star to hide another star. That's really kind of cool. So let me switch back to our storyline here. And if our planet Earth was in a double star system, would it always be daytime? How would a guy get a good night's sleep anyway? So another fun fact for you. We are an oddball in our solar system. Astronomers' best estimate is that 80% of the stars we see at night are actually double stars, 4 out of 5 stars. They're just so far away that our eyes can't detect the second star because it's lost in the light of the first star. Amazingly, many of these stars are bound to each other gravitationally, stars circling each other like our planet circles the sun. Other star pairings are just optical illusions. So that was pretty interesting. Imagine if our planet Earth was in a double star system. It might never get dark at night. Well, I know we said we'd focus on things we can see tonight, but comets visible to the unaided eye don't come along every day, and soon those with very good eyesight will be able to see this summer's most promising new comet, nicknamed Neowise. Comet Neowise is named after the NASA Space Telescope that first spotted it in March of this year. That telescope's name is the Near Earth Orbit Wide Field Infrared Survey Explorer. All those letters come together to make the word Neowise. So they nicknamed the comet Neowise. Now, it's not going to be as totally awesome as Hale-Bopp was back in 1997, but it is cool to see, and those with binoculars are going to get a particularly awesome view. So Comet Neowise has survived its elliptical trip toward the sun and emerged from behind the sun and is on its way back to the icy regions of our solar system. And guess what? Our friend the Big Dipper can serve as a guide again. Watch for the whole week beginning this Saturday as the comet passes from the front paws and legs of the Great Bear through the hind legs of the Great Bear. So at the beginning of the week, you can see that was the head of the bear and there was his eye. The beginning of the week is going to be here and it's going to progress all the way through in this direction, right through there. So Neowise will be visible for just a few minutes on Saturday the 18th, about 10:20 at night, right after the sun goes down. But you're going to need a clear horizon to the northwest because it's really low in the sky. As you can see, there's not a lot of room above that tree there. So you got to get a clear view in order to see it. The best view is going to be about that same time on July the 22nd, when the comet is at its closest approach to Earth and is going to be visible for a whole hour because by that time of night it's going to be higher in the sky than it was when it was down here. It started out down here, and you can see by the 22nd it's about there. And guess what we're going to have for a real nice guidepost is if you open the Big Dipper and it falls open, you're going to see the comet right there. But don't wait for the last day. Look more than once. The clouds in our area are not always friendly. So put it on your calendars because it won't be back for another 6,800 years. Next, we're going to use the Big Dipper to find the 2 other asterisms that, like the Big Dipper, are visible all year long. Those 2 star patterns are known as the Little Dipper in the constellation of Ursa Minor, the Little Bear, and I call it the Big W, found in the constellation of Cassiopeia. So put your bunny shoes on because we are going to hop. Star hop, that is. Our second famous star pattern, visible all year long, is the Little Dipper in the constellation Ursa Minor, the Little Bear, right here. Well, here is our Big Dipper, here, and here is our Little Dipper. So there's a clue for you right there. How do you find the Little Dipper? You find it because you know that the last star in the and the handle of the Little Dipper is Polaris. But I gotta tell you the truth, have you ever really seen the Little Dipper? How about that little bear? Let's call these famous, all right, but invisible. When I try to find the Little Dipper, I find that it looks about like this. I can find the Big Dipper, and I can certainly find Polaris. Hey, these guys on the end of the Dipper, of Little Dipper, are really easy because this guy here is real pretty and he's red. His name is Kochab. So those guys are pretty easy. But these other stars, I really can't see them very often. Sometimes from a really dark side I can, but not from my home. So don't feel bad if you can't see the Little Dipper in our light polluted skies. Many nights it's just not an easy asterism to see. The fun of it is that when we finally get to a place with darker skies, we'll laugh because we know we can nail the location of Polaris. And these guys here stand out like a sore thumb. It is going to be so much fun when we're finally rewarded in a darker spot where we can see all of the Little Dipper. Well, we know two famous star patterns in the sky. They're all year round, the Big Dipper and the Little Dipper, and we can find Polaris and we can find the double star Mizar. Without moving an inch, we can find our third famous all year round pattern of stars by using the Big Dipper and Polaris. Next up is the big W of the constellation Cassiopeia, a constellation known in ancient times as the Queen of Night Sky. Unlike the Little Dipper, she's not shy. Remember how much room the Big Dipper took up? Well, Cassiopeia is in no slouch either. The W is bright and it's really big. Long ago, the story of Cassiopeia included the Queen of the Night Sky sitting on her throne, and that's what people imagine with the Queen sitting on her throne. But to our modern eyes, Cassiopeia's brighter stars look more like a capital W. I think you can see that there, right there. And not a neatly written W, in fact, more of a badly written letter W, where the left side of the W is particularly kind of lazy. That lazy W is our third year-round asterism, and here's an easy way to find it by using the Big Dipper and Polaris. Starting from the handle, closest star to the pot right here, draw a line in your eye from there to Polaris, and then extend that line one more time, and bingo, there you are at the bright W-shaped pattern of stars in the constellation Cassiopeia. Interestingly, these two constellations, Ursa Major and Cassiopeia, are always opposite each other. If one is high in the sky, the other is low in the sky. If one is left of Polaris, the other is right of Polaris. They continuously circle each other in a game of chase around the North Star. Now remember how we learned to look for the Big Dipper by facing north and looking all around an imaginary clock. Remember how we can find the Queen on her throne by using the Big Dipper. Well, the Big Dipper always looks like the Big Dipper, although sometimes the pot is facing up and sometimes the pot is facing a different direction. But look what happens to the Big W when it's opposite the Big Dipper around Halloween time. So I've got this thing set here for 10:31 at 10:30 at night, and we'll follow that same trick. We'll go from there to Polaris, and there it is. Look what happens to the Big W. It becomes the Big M, just in time for football season, when both Michigan State and U of M fans all think Cassiopeia was put there just for them. The stars of Cassiopeia lie in a rich backdrop of the Milky Way. And you can sort of see that because these are the stars that are the lighter of the stars. And you can begin to see that there's not stars in some other places, so many of them, but there's a whole bunch of them here around Cassiopeia. So Cassiopeia lies in the rich backdrop of the Milky Way, which we'll talk about in a little bit. But suffice it to say that Cassiopeia occupies a very rich, star-filled area of the sky, especially well worth a peek if you're lucky enough to have use of a pair of binoculars. Well, now we know the three asterisms that are visible all year long. We know the Big Dipper, we know the Little Dipper, and depending on the month that it is, it could be the Big W, it could be the Big M. Okay, so three asterisms or star patterns, but still no bright stars. Bright stars it is. Put your bunny feet on because we're going to star hop again. And again, we're going to use the Big Dipper, there she be, right there, as our guidepost to find our first two bright stars of summer. And they are going to be Arcturus and Spica. First, let's find Arcturus. And when we're at Arcturus, we'll also find the first of our 5 summer asterisms. Arcturus is the brightest star in a constellation called Bootes. Funny name. Arcturus is also the brightest star in the sky tonight. Magnitude minus 0.1, so just a little bit brighter than that comparison star Vega. The name Arcturus is a Greek word. It means guardian of the bear. So the ancient people saw this as a guardian of the bear, and I'm not even going to show you what the artwork looked like. There was the guardian, there was his hunting dogs, and there was the bear. But to modern eyes, most people see a kite here. Most people see the shape of a kite, with Arcturus being kind of at the tail of the kite. Some people say they see an ice cream cone. I guess I can pretty easily imagine that as well, which would be a real summer treat. But myself, I'm more of a kite guy. So Arcturus is easily found by remembering an old astronomer's jingle. It all starts, like we said, with the Big Dipper. The astronomer's jingle goes like this. It tells us to follow the arc of the handle of the Big Dipper and arc to Arcturus. And when you do just that, follow the arc of the handle of the Big Dipper and keep that arc going, the bright star that you will see, the only bright star that you will see, is going to be Arcturus. And you may remember we talked about Arcturus having a bit of an orangish red look to it. So Arcturus is what astronomers call a red giant, a star much bigger than our sun. It has grown quickly and is destined to explode as a nova when it's finished its process of turning nuclei into more complex elements. So that was Arcturus, and our second star is Spica. Its magnitude ranking is an even +1. Bright, but not as bright as Arcturus. Okay? The second half of that same astronomer's jingle is going to help us find Spica. It goes like this: arc to Arcturus, and then spike to Spica. So you're pretty much continuing that same arc pattern, arcing to Arcturus, and then spiking to Spica, because it's a nice rhyme. Or some people say speed to Spica. Well, Spica is the brightest star in the constellation Virgo, and there I've shown you not only the line diagram of where the brighter stars are in Spica, and you can see there aren't very many. Our guy here, Spica, is the only bright star in the whole group. But I've also shown you this image of what the ancestors saw. The picture showed here is one of my favorites because the maiden is holding an ear of corn right there. Spica is the star that was seen as the ear of corn. Hundreds of years ago, people would know when they first saw Spica in the springtime, it was time to plant their crops. The name Spica comes from the Latin language, and it means the Virgo's ear of grain. Well, like so many other constellations, the Maiden is tough to imagine, and many of the stars in the constellation are dim. So there's no asterism to share here, but that ear of corn star, Spica, that is easy to spot. Earlier this evening, we looked to the northern sky. We found 3 cool asterisms, but no bright stars. Now we found our first 2 bright stars of summer, Arcturus and Spica, and 1 asterism, the Kite, up here in Arcturus. So to find our way in the night sky, we need all the help we can get: bright stars, star patterns, and stories to find our way in the night sky. I hope you're pretty limber because I've asked you to do some twisting around. We've started over here, we've turned our necks this way, but now we're actually looking into the southwest. So unpretzel yourself if you're tangled up, and let's go for some more fun. Our third bright summer star, Antares, known as the heart of the scorpion, and it is due south. So here we are looking due south now. Find Spica again, and look to the left, just about the same distance above the horizon. Go from Spica, and you will not miss Antares. It is the third it is the third bright star, and it twinkles. It's red and it twinkles. It is an amazing star. It's found in the constellation named Scorpius, and I'm showing the artwork again because the constellation is one of the few that looks like its name. It doesn't take much imagination to see the scorpion that legends have described for thousands of years. You can sort of imagine some claws here, and his beating red heart, and the body, and finally the tail with the stinger, with the two stars and the stinger. So uh, Antares and this whole constellation, the Scorpion, is one of my favorites. The star Antares, particularly, is in a class of stars known as red supergiants. Among the bright stars that we see throughout the year, the only comparable star is a star that was much in the news this past winter, Betelgeuse, in the constellation Orion. Betelgeuse is gone right now, but what a lovely sight Antares is. It's fun to be able to locate him due south in the summer sky, and it's also fun to know a few more facts about Antares. First of all, let me share, it is huge, even bigger than Betelgeuse. Last measured in June of this year, just last month, it is 700 times bigger than our sun. So if Antares was in the same spot that our sun is at, Earth would be burned to a crisp with a marshmallow left in the flames too long. The star Antares is so big, its size would gobble up Mercury, Venus, Earth, and Mars, and even reach a large portion of the way to Jupiter. Its atmosphere would reach all the way to Uranus. That one star by itself is almost as big as our whole solar system. That, my friends, is one big star. Well, Antares is huge. And secondly, the star Antares is noticeably red, very red in color. With its distinctive color, Antares could even be confused with the red planet Mars. Here is Antares, I circled it for you. And over here is Mars. You can see they are pretty similar in size and in color. So you can see why it's easy for how Antares got its name. So let me tell you the story. Both the Greeks and the Romans had a name for this planet here. The Romans called it Mars, the same name that we do, but the Greeks called it Ares. The name Antares stuck for the name of the star. Antares literally means rival of Ares, or to our modern ears, rival of Mars. Both are distinctively red-looking objects vying for your attention in the summer sky. And that's the story of how Antares, the beating red heart of the scorpion, got its name. By the way, full disclosure, the planet Mars does not rise from the eastern sky tonight until well after midnight. But Mars can serve as a clue for us about our next treasure of the sky. And the clue is this: not every bright object is a star. From Antares, the heart of the scorpion, bring your gaze down halfway to the horizon, and then continue our journey moving to the left until you come to stars so big that your eyes can't believe them. And guess what? It's not true anyway. Those are planets. Hands down, the brightest object in tonight's sky is Jupiter, the biggest planet of our solar system. Now, to our naked eye, Jupiter looks about like this, a bright star. But if we could look through a telescope, we could see the bands of clouds, which are very colorful, and it's just beautiful. Um, that red spot that we see over here is actually a big cyclone storm. It's been there for about 340 years. And you thought it was cloudy here in Michigan. And by the way, that storm is very big. Our whole planet Earth could easily fit inside of that cyclonic storm. At 10 o'clock tonight, Jupiter is just rising over the southeast horizon. If you can't see it, move to a clear sight or just wait a little bit, as it will continue to rise quickly in the sky. And as luck would have it, tonight is a great night to look at Jupiter. First, we have clear skies, but also right now, Jupiter is as close to planet Earth as it will be all year. That means that it looks its biggest and its brightest tonight. Actually, it's tomorrow night. It's pretty close. And just because it's fun to know, I know you can't see it, but just below Jupiter tonight is where you would find Pluto if you had a telescope. At 10 o'clock tonight, we have another planetary treat, Saturn. Saturn is just cresting also over that southeast horizon, poised a little to the left and just a little bit below Jupiter. Again, with our eyes alone, Saturn looks like a bright star, although Jupiter is clearly the bigger of the two. If we were to go back and look at that, it's true, Jupiter is clearly the bigger of the two, no doubt about that. Um, 1 week from tonight, Saturn will also be at its closest point to our planet, and it will look its biggest and brightest of the whole year. So the view of Saturn in a telescope, to tease just a little bit, is mesmerizing. It appears to float in the night sky on gossamer rings. But our goal tonight is to enjoy what we can see without telescopes and to feel a sense of kinship when we see these bright objects in the sky, to be able to say, hey, I know those guys. They aren't stars. Those are our beautiful planets, Jupiter and Saturn. Well, in our hurry to get to Jupiter and Saturn, we passed by something else very interesting, the second of our 5 summer asterisms. Look just to the right of Jupiter and see if you can imagine, can you see a teapot in here? A handle, a top, a spout, and the rest of the kettle, kind of like that. Let's take another view at it and let me magnify what those lines might look like so you can see them just a little bit easier. There, now it looks pretty much like a teapot. The constellation we're looking at right here is called Sagittarius, but most of Sagittarius is below the horizon where we can't see it. The part that we can see, however, doesn't look as much like an archer as it does a teapot. That is the asterism of the Teapot in Sagittarius. Unfortunately, those stars are not quite as bright as some of the other stars in the sky. And even worse for us, where we live, we're at a bit of a disadvantage when we try to look that direction to the south directly. Not only is this asterism low on the horizon, as you can see, so it's got a whole bunch more air that we're looking through, but also we're looking directly at the bright city lights of Troy, Royal Oak, Detroit, and Windsor, competing with the beauty of the sky. You can try to squint your eyes sometimes to pick out the stars. It's really not that hard. And it's easiest on nights like tonight when the moon is also not shining in that same southern sky. So tonight is a good night. Well, don't look away just yet. You may have noticed something else here that almost looks like some steam rising from the teapot Sagittarius. Well, it's not really steam. What looks like a faint stream of steam is actually the Milky Way. I have made this picture of the Milky Way look its most favorable, like you might see it if you were camping out north, and surely like you'd see it if you were out in the desert out west. Sadly for us, it won't look as beautiful. But we said this scheme is the Milky Way, but we never really explained yet what the Milky Way is. So to appreciate the Milky Way, we need more of a sense of perspective. We need to think big, big patterns. Think really big patterns. Think solar systems. Think galaxies. Consider our solar system. That's us here. We think of our solar system as forming a very big pattern. The larger objects of our solar system, including our sun and 8 planets, seem immense to us. From our perspective, this pattern of planets, heck, Earth is nearly 93 million miles from the sun, and it takes light 8 minutes to get here from the sun. That's a long distance. You think, wow, light travels 186,000 miles a second, and it still takes 8 minutes for the sunlight to reach us. Well, we know there's a lot more to see than the planets. We see a lot of stars too, and here's the explanation why. There's big and there's really big. Our sun, with its solar system, is only one of about 250 billion stars in a very large collection of stars known as a galaxy. So now we're thinking really big. Let me repeat that. Our sun, with its solar system, is one of about 250 billion stars in a very large collection of stars known as a galaxy. This drawing on the screen tries to tell us where we're at in this galaxy. But truthfully, the size of our solar system in this drawing is greatly exaggerated and should be little more than a pinpoint of light, a pinpoint of ink. So let's answer that question that we asked a moment ago. What is the Milky Way? What is that stream of light in the night sky that looks like steam rising from the T-spout of Sagittarius? It's light, but it's not a star. We can directly see a few thousand of these 250 billion stars in our galaxy. And the stars we do see look so small they look like pinpoints of light. The rest of those 250 billion stars are so far away that we can't see them individually, and at best we see a faint glow of light. So when we see the Milky Way looking like steam rising from the teapot of Sagittarius, we're seeing this faint glow from billions of distant stars in our galaxy, light that is so distant that it cannot even be resolved into individual stars. So now, Tierney, if you're still with me, I would like you to put up our next question. I think you have it listed as number 5.
Yep, that's
And
right.
to me, it's the most important thing we're going to talk about tonight. So go ahead, Tierney.
Sure. All of the stars that we see with our eyes at night are found in our galaxy. Is this true or false? We'll give you about 30 seconds to put in your answer.
You know, it looks like it's pretty evenly split again, doesn't it?
It does, yes.
So,
Almost. Mm-hmm.
yeah, 4 out of 7 thought that all of the stars, well, let's do it the other way. 3 out of 7 thought that all the stars we see at night are found in our own galaxy, and the rest thought no, not true. So, the answer is yes. All of the stars we can see with our eyes tonight are going to be stars in our own galaxy. So imagine that 250 billion stars. And of all those stars, tonight we're talking about six bright summer stars that we can see from where we live. 6 stars out of 250 billion. Yeah, the Milky Way is big. Well, that, my friends, is the story of the stream of steam rising from the teapot of Sagittarius. And the Milky Way is our view into the rest of the Milky Way galaxy. Not sure why that's not moving. There it goes. And to complete our thought about thinking big and then thinking really big patterns, I'd like you to look at this picture. What you're looking at here are not stars. Each one of those objects you're looking at is a galaxy. For 10 straight days in 1995, the Hubble Space Telescope stared purposefully at a tiny and nearly empty patch of sky near the Big Dipper. The telescope gathered all the light it could, slowly building a picture, and what emerged is this Hubble Deep Field, and it revealed galaxies fainter than had ever been seen before. In this one picture, there are over 10,000 galaxies. So astronomers' best guess is that there are billions of other galaxies. So that's the biggest pattern we'll talk about tonight. So back to our story about tonight's bright objects. When we see those 6 bright stars in the summer night, those are some of the closer or bigger stars in our galaxy. And when we imagine the stream of steam rising from Sagittarius' teapot, we're seeing a faint glow of light from billions of distant stars in our galaxy. Because of the glow of these distant stars, our view of the galaxy looks milky white intermixed with some swirls of dark, and that is why it's called the Milky Way galaxy. And now's a great time to see this Milky Way of starlight as our planet traverses around the sun. Right now, we are poised to look directly at the center of our galaxy. So on summer nights like this, we are looking that direction, which explains why it looks as cool as it does. So put this on your bucket list. You must absolutely find a dark space to see the Milky Way. Well, we still have 3 more bright summer stars to share. So following that path, a little bit exaggerated path of the Milky Way, all the way up from Sagittarius to Cassiopeia, we encounter the last 3 noticeably brighter stars of the summer sky, and those are Deneb and Vega and Altair. These 3 stars form what is affectionately known as the summer triangle. It's the third of our 5 summer asterisms, and it looks like this. Now, I've left these constellation lines on for the various constellations, so you get an idea that we are looking at something really, really big here. This asterism spans this constellation in Vega and Altair. So again, think big. This asterism, the summer triangle, is 3 constellations wide. These 3 stars anchor us throughout the summer nights, and this distinctive pattern of stars will be visible long into the fall, when this asterism will eventually be replaced by yet another asterism, which you may have guessed will be called the winter triangle of stars. So as we talk about these 3 stars, I'm going to throw a few numbers at you, but I don't want you to get glassy-eyed over them. Just think what I'm talking about as something fun, a mind-bending thought. It's this. Sometimes a dimmer star will look brighter to us because it's closer to us. Sometimes a star farther away will look dimmer to us, even though it's really a brighter star than the nearby star. Vega, of these 3 stars, appears to be the brightest. You may recall it was our ranking star for visual magnitude. It was ranked at 0 magnitude, so everything is either bigger or brighter or less bright than Vega. Vega is found in a constellation, a small constellation called Lyra. Now, most constellations are named after ancient gods and goddesses and legends and heroes, but what happened here? Try that one. Only a few constellations are named after objects. So Lyra is one of these few. The bright stars of Lyra were thought to form the shape of an ancient harp, which was also called a lyre, which you can see a couple of the stars barely in here. So that's what the ancients saw, and you can see how easy it is how the name Lyra came from a harp lyra. So during the summer, Vega will continue to rise higher in the night sky, and if you lay on the grass this summer, you look straight up in the night sky, Vega will be right above you at the zenith. That is, at the top of your view. Very easy to find. Don't worry if you don't see a lyre. Vega is sure to catch your eye. Altair is found in the constellation of Aquila, the eagle. And it's the second brightest looking star in the summer triangle, and it's a magnitude of 0.8. A little less bright than Vega, a reference star of 0 magnitude. So of the 3 stars in the summer triangle, Altair is closest to us, 16 light years away. Vega's a little further, 26 light years. And here comes the fun part, Deneb. Deneb, the 3rd brightest star to our eye, at a magnitude of 1.3, so just a little bit less bright to our eye than Altair, is the farthest of these 3 stars at an amazing 1,630 light years from Earth. So magnitude is a useful measure because it ranks stars by brightness, the way they appear to us. But as we're starting to get a glimpse, distance from Earth plays a big role in how bright things appear. From just these 3 stars of the summer triangle, we can see that a closer star like Altair can seem brighter to us than a more distant star like Deneb. Deneb's light has been traveling for a very long time compared to Altair's light, but if we could put Altair and Deneb side by side at the same distance from Earth, so the light of each star traveled the same distance at the same time, Deneb would trounce Altair. Then it would look like a star that was a minus 6.8 magnitude star, and Altair would look like a plus 2.3. I can't do the math in my head, so I looked it up. Deneb is almost 4,000 times brighter in reality than Altair is. Multiply 2.5, which was that method that the guy came up with, remember 1856? They came up with a new definition, 2.5 times brighter. Do that 9 times, and it comes out to be 4,000 times brighter. So today, astronomers measure not only the apparent or visual magnitude of stars, that is, how bright the star's light is when it finally reaches our planet, but they also try to put the stars on a common footing to measure each star's real or intrinsic brightness. They call that measurement the absolute magnitude of the star. Well, that's the end of throwing numbers at you, but I thought it might be fun to know. So while we're here looking at this bright triangle, I'd like to spend a little bit of time talking about Deneb. Deneb is one of my favorite Deneb in the constellation Cygnus. Cygnus is one of my favorite constellations. Um, the name Deneb, incidentally, comes from the Greek, and it means tail. So knowing the name of this as the tail, where did my cursor go? We now know which direction Cygnus the swan is flying. That's the tail. That's got to be the head. And those are the wings. I can very easily imagine that. It looks like a long, lanky body of a swan, and those definitely look like wings. And there's the beak or the head. And another interesting fun part about this constellation for me is that the head of the swan is a star named Alberio, which appears to the naked eye as a single star, but is actually an exquisite instance of a double star. Michiganders call Alberio the U of M star because it's a beautiful set of maize and blue stars. Sorry for the tease, you will need a telescope to truly appreciate this double star. But the Northern Cross is also found in the same constellation, Cygnus. The Northern Cross is the fourth of our 5 summer asterisms. There is a famous asterism in the southern hemisphere called the Southern Cross. Not to be outdone, many folks in the northern hemisphere look at this constellation Cygnus, and instead of a swan, they see the Northern Cross, which we too can easily imagine. The Northern Cross is the fourth of our 5 summer asterisms. The fifth and final summer asterism, excuse me, is found here in the constellation Hercules, and it is the Keystone, is what it's called. It's perhaps the least visually intriguing asterism of the summer sky. Draw a line in your mind's eye from the two brightest stars of the night, Arcturus to Vega. We'll pass through the northern crown, which looks a lot like a tiara late at night, and there's a bright star. So on your way through that crown, you'll come to this shape here. Oops, there it is. You'll come to this shape here, which is the shape of a keystone, the kind of a brick or stone that we use in the creation of a bridge. Now, again, I say it's the least interesting. I think the real reason why astronomers take such note of this asterism is not because its shape is so intriguing, but the real reason is because right about here, about a third of the way down on the western edge, is where we find a particularly interesting object known as a globular cluster. And hopefully we'll have some time that we can show you a photograph of this particular globular cluster. So for now, this tour of the night sky is over. It's our fondest wish that you'll be able to step outside later this evening and try to find one or more, as much as you can, of the things that we talked about. So I'd like to consider, what do we know then about tonight's Oakland County sky? Like bunnies, we've learned to star hop, find our way among the stars using bright stars and star patterns. So to summarize, we looked east and west and north and south and concluded there are only 6 truly bright stars in the summer sky, all on the southern horizon. We looked toward the top of our spinning planet Earth to get our bearings and learned to find the Big Dipper at any time or date that we look. Using the Big Dipper, we found Polaris, the North Star, which we now know for a fact is not the brightest star in the night sky. Using the Big Dipper, we found the 2 other asterisms that are visible all year long, the Little Dipper and the Big W. Surprisingly, we noted that none of these 3 asterisms has really bright stars in them, but we recognize patterns. We found a double star in the handle of the Dipper, and we are prepared to become comet watchers, looking underneath the Dipper's pot for that surprising new comet, Neowise. From the Big Dipper, we followed old Jingles to locate the 6 seasonal bright stars of summer and notice a variety of beautiful star colors. We started with an arc from the handle of the Big Dipper and followed it to the southwest to Arcturus, the guardian of the bear, the tail of the kite. Then we spiked to Spica, the ear of Corn Star. Continuing to move to our left, now due south, we were awed by the blinking red heart of the Scorpion, Antares. We could not help but be distracted by the behemoths of our own solar system, Jupiter, the king of planets, and the ringed wonder Saturn, both just rising in the southeast sky. We returned to where we began, looking due south, to find the second of our 5 summer asterisms, the Teapot in Sagittarius. We learned about the Milky Way, its upward path, easily remembered as steam rising from the spout of the pot. We followed that steam higher in the sky and were rewarded with 3 bright stars of our third asterism, the Summer Triangle, Vega, Deneb, and Altair, where we learned that there are 2 measures of magnitude, visual magnitude and absolute magnitude. With Deneb at the tail and the double star Albireo at the beak, Cygnus the swan was transformed into the Northern Cross. And we found mighty Hercules bridging the stars in the night sky with a keystone asterism. There is a part of us that wants to feel one with the night sky. Somewhere deep inside, we find it rewarding to look at the sky and say, I know the name of that bright star. I see it every summer. Well, we hope we've made it a little easier to find your way in the night sky, and by doing so, to enhance your enjoyment of its beauties. Thanks for sharing tonight's sky with us. We hope you found the presentation informative and entertaining. And again, the stars are ours to enjoy. There's no right or wrong. Just don't pass up the opportunity to be amazed. As promised, we'll leave this final slide up on the screen for a while. It contains links to names of websites and books that we talked about during the presentation. And the same list of citations is available on our club website under the Observations tab. Gary, I wonder if you have a chance to pick up any questions or if there's anything you'd like to add. And then after that, maybe we can look at a few of the beautiful pictures that we have.
I don't have any questions at this point. That doesn't mean that somebody still can't type one in and send them over to me. I'd be certainly glad to try and answer them. One additional point about your slide that you have up there right now is some of those free download apps in the middle. There's several of them that are they're very inexpensive, if not free, and $1 or $2 at most for some of them, but they allow you to have on your smartphone basically a guide to the night sky. You simply point your phone, you invoke the application and point it at the sky, and it'll tell you all the different stars, constellations, planets, everything that's up there, including even satellites. So there are several of them. John lists Celestron's Sky Portal. I use 2, one called Redshift and another one called Skyview. And another very special one that I like using too is the ISS spotter, which is the International Space Station spotter. Again, that's free, and that's visible. You download it on your phone, and the space station is visible to the naked eye going across the sky. Not every night, but it also gives you a forecast of when it is coming over our particular area so that you can see it. But I would strongly recommend to any of you to be able to load one of those onto your smartphone, and it immediately allows you to become much more understanding and knowledgeable about the night sky. That's probably all I had, John.
Yeah, the interesting thing about that ISS spotter, I think this week, in addition to all the other good things happening this week, I mean, Jupiter's at opposition, we've got the comet coming, and I didn't look, but someone had just told me the other day that the International Space Station was going to put on a real show this week in our area of the world, so it might be a good time to try to catch that ISS.
I just got a question. Maybe we can answer it live here. It's what color star is the hottest?
Oh,
John, you want to take that?
Yeah, the hottest one is definitely the blue-white. That was our Spica star. That was about 46,000 degrees Fahrenheit. The ranking of the stars is from blue-white to white, yellow-white, yellow, orange, and red. So Spica is at the very top of the range, about 46,000 degrees. Our sun is way down there as a yellow star, about 10,000 degrees. And some of the less
you kind of think about your fire in your fireplace or something outside, and imagine all of the different colors in that, from yellow, red to white and blue. Well, the hottest parts are exactly the same as our fires are, like John just described too.
Yeah, good. So if we don't have any more questions, we could show a few of these beautiful pictures that we have. Do we still have time, Tierney?
Yep, we have about 7 more minutes. So as we're looking at the pictures, still feel free to add questions to the chat. We'll keep an eye on that.
Okie dokie.
Yep.
If you do need to head out, we understand as well. But yes, the pictures are going to be wonderful, so please stay around.
Okie dokie. Well, this is a picture of Comet Neowise that Gary and his wife got up early this morning and took with their digital camera. And you can see the tail of the comet, and you can see it right there. And Gary, what time of the morning was that?
This is at between 4:30 and 5 a.m. It's pretty early.
Mm-hmm.
It will be visible at that time this morning too. It'll be I think it'll be probably the last morning. Maybe there's a couple more mornings you can also see it. But if you look into the northeast sky at between 4:30 and 5 a.m., hold your fist out in front of you and put the bottom of your fist on the horizon, and the comet should be about that width above the horizon. It's about 10 degrees.
Mm-hmm.
But this morning it was brilliant. It was very bright and really, really nice to look at.
Now, I also heard that by Thursday night it's going to start to climb a little bit. It'll start, instead of being a morning star or morning comet, we'll be able to see it at night. And it's going to be around 10, 12 degrees by Thursday, 15 degrees, something like that.
Yes.
And by the 22nd of July, it's going to be visible for a whole hour. And the show goes on all the way through August, mid-August, but it gets dimmer and the tail gets shorter. And of course, trust no one. The clouds come and the clouds go. So don't just try looking for it once. Take your first opportunity, because it won't be back for another 6,800 years. So we do have some more for your enjoyment. We have some lovely pictures here provided to us from Dana. And remember when we told you that astronomers like that keystone asterism because it helps them find some really neat things? Well, this astonishingly beautiful globe-shaped cluster of nearly 1 million ancient stars is a favorite of amateur astronomers. It's the globular cluster called M13, found about a third of the way down the western edge of that keystone asterism. It's so bright that on a really good night, you could detect it with your naked eye if you were young and had good eyesight. Well, this is not another galaxy. This cluster of stars, and there's about 150 other globular clusters that we can see. They circle around the nucleus of our galaxy, not like the other stars, not in the plane of the galaxy, but around the nucleus. And they're just amazing to see. So that was a globular cluster, and you would think, oh, the stars start out close together and then they spread out like this. No. Actually, the stars you see here are the oldest stars uh, in our Milky Way galaxy. Um, and they all are so close, and so many of them hanging out together. They're so gravitationally bound, they have not dispersed. Whereas here, what we're looking at is an open cluster, and you can see there's actually two distinct groupings of clusters here. There's one here and one here, and the stars are beginning to disperse. So all of these stars were gravitationally bound still, but they are beginning to break up. And so this is that area we said in by Cassiopeia, a very rich star region of the sky. Just a little below and to the left of Cassiopeia, technically in the boundaries of another constellation called Perseus, is where you found this beautiful, Dana found this beautiful variety of open clusters. You want to add anything there, Gary?
No, I think you covered it pretty well.
Okay, okay. And this here is my favorite. Happen to have taken this picture myself, and this might look like a flying saucer to you amongst the stars, but it's not. This was a star like our sun that was in the process of converting its hydrogen to heavier elements, expanded to become a red giant, and it expelled all of its outer layers. And you can see that right there, expelled all of its outer layers. Meanwhile, the core of the star, which you can't really see, collapsed into an immensely dense ball, no bigger than the Earth, and we know that as M57, the Ring Nebula, not a cluster of stars like the globular cluster M13, just the glowing gas remnants of a one-time pinpoint of light. So you remember when we watched the Big Dipper moving around a circle around Polaris? Well, in this beautiful picture, Dana photographed the star trails of the northern night sky at Arches National Park in Utah. Well, Gary, you've been there, haven't you?
Yes, I have. It's one of the best dark sky spots around. They have some of the clearest skies, all of them, in many of those parks out in Utah, Arizona.
Yeah,
They're fantastic.
so the camera has this ability to record starlight for hours, and each little pinpoint of light grows and grows and eventually becomes a circle around Polaris. Here's another beautiful star trail photo looking north from the Hobby Eberly telescope at the McDonald University, which is in McDonald Observatory, which is in southwest Texas. Now you may notice that Polaris, right there, may seem to be lower on the horizon when we look at it than it was when we looked at our location. It was way up here. Well, here's a fun fact for you. From any latitude on Earth where Polaris is available or visible, Polaris will be located the same number of degrees above the horizon as the longitude from which it's being viewed. So here in Rochester, it's 42 degrees north of the equator, and we find Polaris up here 42 degrees from the horizon, whereas down here in Texas, where they're located at the 30th degree of latitude, Polaris is found here and much lower in the sky. Just a couple more. In this amazing photo, my very favorite, is near the belt of Orion. Here, Dana has captured a glorious picture of interstellar gases, the materials from which the stars are formed. Two easily imagined shapes here. This one here is called the Flame Nebula. This one here you may have heard of, and it looks like a horse head, called the Horsehead Nebula. Impossible to see these things with the naked eye, but Dana was able to capture them with his camera and share with us these majestic vistas of hidden gases. So all of the stars we see tonight are stars of the Milky Way galaxy, yet visible with the naked eye on a clear night at a dark sky location is something we can see that's not a star. It's a smudge of light that is not part of our galaxy. Looks much more amazing in Dana's photograph. This is the Andromeda Galaxy. It's captured in exquisite detail, and we can see the spiral arms of the galaxy starting to form there. All these other stars we see are stars in our galaxy, although he did capture one other galaxy right up here. So here's one more fun fact to know. Andromeda was not recognized for what it is, another galaxy, until 1925. Edwin Hubble is credited with proving Andromeda is not part of our galaxy. You may recognize that name. So this new understanding of what's up there began to broaden our understanding of the universe. And today, with the aid of the telescope named after Edwin Hubble, we know there are billions of other galaxies. Astronomy is an amazing science, one that continues to challenge our perceptions, as we saw earlier in this amazing ultra-deep field photograph that you can download from the NASA website. It makes a wonderful screensaver. Finally, don't forget Luna, close at only 250,000 miles away, just a little over a second if we could travel at the speed of light, was our nearest neighbor, Luna. Humans have successfully traveled this distance and landed on the surface of the moon only 6 times. Those trips occurred over the course of 3 years, from 1969 to 1972, at a time when human computers were needed to perform difficult calculations, because the computers of the time were not anywhere as rich as today's dumbest smartphone. And in exciting news, planning is underway to send astronaut explorers back to the moon for the first time since 1972. NASA's funding and thus its timeline is being pushed back even as we speak, but at least the process has begun. So stay tuned for more to come. And that's about the end of our presentation, Tierney.
Yeah, wonderful. Thank you so much, gentlemen. That was fantastic. Thank you, everybody, for coming tonight. Really appreciated it. And thank you again to the Oakland Astronomy Club. Yeah, that is the end of our presentation. So thank you for coming, everybody.
Okay, thank you very much.
Yeah.